Hey everyone, Michael here. Welcome to the channel. I have not posted in a while. I've been looking for a new job, which has been taking up all of my time. But today I have another algorithm video for you going over the popular problem, merge k sorted lists. If you are not already subscribed, you should definitely consider doing so. I do plan to post a video every single week. And without further ado, let's get into the video. Okay, so for this problem, we are given several linked lists in an array. Each linked list is sorted in ascending order, and we must merge all of the lists together to be one long sorted linked list. There are many ways to solve this problem. For the brute force approach, we could simply iterate over all the linked list nodes and add them into an array. Then when we sort on the array and loop through to make the connections between the nodes, this would be a big O of n times log of n time complexity algorithm, where n is the total number of nodes we have, but we can most definitely do better than this. So let's jump straight into the optimized approach. Keep in mind this is of hard difficulty. So the knowledge of the merge sort algorithm is very prevalent here since it will involve a divide and conquer approach. So there are two steps that we're going to need to perform. The first step is dividing the lists continuously until we have a single list, which is our base case. And then our second step is to merge the divided lists back together, sorting them in the process. The intuition behind this approach is we will be merging together sorted lists in multiple parts of the array recursively, hence the divide and conquer. The good thing about this problem is once you understand the divide and conquer approach for this problem, many other divide and conquer problems are easier to solve. In terms of merging two lists together, I have another video that goes over that exact logic, so feel free to check that out. The link will be in the description. But for now, let's look at the following example. At each step, we're going to have a start and end index. Start is going to be at 0 and end is going to be at 2. And as you can see, start is on the leftmost side of our array and end is on the rightmost side of our array. So with these start and end values, we're now going to compute a midpoint. So if we do our start plus our end divided by 2, that would equal 1 in this case. And what this is telling us is that we are going to split our array based on this midpoint. So the left side will be start mid inclusive, and our right side will be mid plus 1 end inclusive. And we're going to continuously do this until we arrive at our base cases where our start index is equal to our end index. So after splitting at index 1, we now have the following lists, and we're going to recursively do the same logic over and over again until we arrive at the base cases. So now let's do the same thing with the left side again. Now our start is going to be at 0, and then our end is going to be at 1. So if we do our start plus our end divided by 2, that would be 0. And that means we're going to split at 0. So we're going to have one list, which is 145, and another list, which is 134. So now, as you can see, after we did that, the division resulted in two base cases since each list is on its own. What this means is now we just need to go back up the chain and merge the lists together. So 145 gets returned from our recursive call, and 134 gets returned from a separate recursive call. And then we're going to merge them back together, and that would result in an array of 1, 1, 3, 4, 4, 5. Now, if we go back and look at the right subtree in a previous division step we did, we were left with a base case of 2, 6. This will get returned, and now we are going to merge 2, 6 with the previously merged array. And merging these lists together should result in the following array, and this gets returned to the parent call, and that will be our final answer. Okay, so let's go over the code for the solution. We are given an array of list nodes, which will be the head of our linked lists, and then we need to return a list node, which will be the head of our merged long linked list. So the first thing we want to do, we need to check if our list input is even valid and make sure we handle that. So we can say if our list is null or our list length is 0, then we can just return null immediately. Then we're going to need to create a helper function, and this will be the actual recursive function that is utilized to do the divide and conquer approach. So we can come down here, and we're going to say return merge k lists. And we're going to pass in our lists, our array of linked lists. And then we're going to have two more inputs, a start and end index that we talked about. So our start index will start at 0, and then our end index will start at the very last index of our array. So we could say lists.length -1. And now we just need to actually create the signature of this function. So we can say private list node merge k lists. We're going to pass in this array of list nodes, and then we're going to have int start and int end. And so now the first thing we want to do inside of this recursive function is we need to handle our base case. So remember, our base case is when our start and end index are the same. If that is the case, that means we are only dealing with a single linked list, and we can immediately return it. So we could say if our start is equal to our end, then we're going to say return lists at the start index. So that's our base case. Now we need to compute our midpoint. So we could say int mid equals start plus end minus start divided by 2. And so the reason why I'm writing it like this is to handle overflow. If our start and end are really large integers and we try to add them up, then that could result in an overflowed number. So this is technically the same thing as saying start plus end divided by 2. You could technically write it that way as well. And now that we have computed our midpoint, we're going to call our recursive function on the left and right side based on this midpoint. So we can say list node left, and we're going to call merge k lists. We're going to pass our lists in, and we're going to pass in our start, and then our mid will become our new end for this recursive call on the left side. And then we're going to pretty much have the same logic. We're going to say list node right, call merge k lists, pass in our lists, but this time our start will become mid plus 1, and then our end will be the actual end that we passed in. And now when we come back from those recursive calls, we're going to merge the left and right linked lists together. So we're going to say return merge of left and right. And so this is pretty much the entire divide and conquer approach. Now all we need to do is implement this merge function. And so we can come down here. We're going to say private. We're also going to return a list node merge. We'll say list node L1, list node L2. So we need to create a result that we're eventually going to return from this function. So we can say list node result equals new list node. And we can initialize this to really any dummy value. So for now, I'll just say it's -1. And then we're going to have another list node, and we'll call it cur, and it's going to point to our result. This cur list node is what we are going to continuously move as we are comparing the elements in L1 and L2. So this will make more sense in a sec. And so now we're going to say while L1 is not equal to null or L2 is not equal to null, if either of those cases are true, then we're going to compare the values. The reason why it has to be an or and not an and is because L1 and L2 could technically be different lengths, and we want to make sure that we merge all elements in both lists. If we did an and, there is a chance that it wouldn't get to every single element if they were different in lengths. So now from that, we can say if L1 is equal to null, then all we need to do is say cur.next is equal to L2, because if L1 is null, we know L2 must have a value. So we can immediately set it. And then we're going to move L2 forward. And then we're going to say else if L2 is equal to null, pretty much the same logic, just with L1 now. We're going to say cur.next equals L1, and L1 equals L1.next. And now if we make it to this case, we know that L1 and L2 are not null, and we need to compare their values to see which one is less. So else if L1.val is less than L2.val, then we're going to say cur.next equals L1, L1 equals L1.next, and else we know L2's value must be the lesser value. So we could say cur.next equals L2, L2 equals L2.next. And then when we come out of all of these different checks, we're going to move our cur list node forward. So we could say cur equals cur.next. And then finally, when we come out of the while loop now, all we need to do is return result.next. The reason why we're not going to return result is because, remember, result has a dummy value of -1 right now. So we return result.next, which is the head of those merged lists. And so that is it for the divide and conquer approach. Let's submit to make sure it works. So our time complexity is going to be big O of n times log of k, where n is the number of nodes that we have when we are merging two lists together. So we take L1's length and L2's length, and then we sum them up. That would be n in this case. And then the log of k portion comes from our recursive function merge k lists. K is the number of recursive calls that we're going to have. And then as for our space complexity, it's going to be big O of k, where k is also the number of recursive calls that we're going to have to make. Since every time we make a recursive call, it fills up the stack space, we have to add that to our space complexity. So it's big O of k. So thank you everybody for watching. I hope you enjoyed this video and got some use out of it. I'm going to be releasing more videos this week, obviously going over more algorithms. So if you have any other algorithms that you want me to solve, definitely feel free to comment and I will try to get to them. If you aren't already subscribed, definitely do it. It really helps out the channel. And check out my Patreon if you want to support me further and have access to the private Discord channel. And with that, I will see you guys next time.